Good afternoon, everyone. If you can hear me, just say hello. Hear it? You can say hello. Can you hear me? Great, go ahead. Kevin?
Yeah, can hear you. I think I was joined as a viewer, so
Got it. Okay.
yeah, I think most of the people might be in the same boat.
Yes, I think so. Let me see if I can
Yeah,
transfer
Rohan,
it.
we can hear you, but yeah, we joined us here.
Got it. Okay, so if you want to talk to me, you can just raise a hand and then I can move into contributor or let's see, make contributor. Oh, that's a lot of work. Anyways, let me do it. Okay, so I'll look as contributor now. So this is mostly a Q&A session, so there's not much that I have. There's something that you have to ask. So if you have any question, then you can proceed.
Hello,
Go ahead, Kevin.
good afternoon.
Yeah, so there are multiple courses, right? So would you be able to kind of map out like which each of these courses, like what they do, and then where does the EAG fit in? Plus, what sort of experience is expected? And even if we think like there's no experience of ML required, but what level of work somebody who doesn't have that experience would need to put in.
Got it. Okay, so I've tried to make a lot of people contributor. If you have question, then just raise your hand. I'll try and make you also contributor and bring the, I was about to say class, but bring the, okay, so let's go to website. We have a few courses there. And if you go on the course, we have EAG right now. And along with that, we have ERA, which is this one. And after that, we have EPAI, and then we have MLO. So essentially, there are 4 courses. We have EAG, we have ERA, we have MLO, and then we have Python course, which is EPAI. Okay, now anyone who knows basic Python can take ERA course, and anyone who knows LLMs and other models in detail, they can take MLO course. So ERA is designed for people to understand how do we train LLMs from scratch and how do we actually get to the state of art. So everything about neural networks from scratch is covered in ERA. Now ERA goes in detail as much as possible, but it essentially sort of stops at a foundation level or the base model level for nearly all the use cases. And it will go up to SFT and reinforcement learning also, but it will not pass on that boundary and go deeper into RAG or the application development from there. So ERA is essentially for someone who wants to understand how LLMs are trained, how do we make a new one, what are the foundational concepts behind the LLMs. So this will be more for people who are wanting to create their career on the model development side. Now, MLO is on the deployment side. So MLO stands for extensive machine learning operations. So everything that relates to continue to tune a model, CI/CD for neural networks or Kubernetes or Dockerization model scaling up, everything for that goes inside MLO. Now, people can create LLMs as a black box and try and take this, but generally, a lot of concepts are going to be used for in MLO, which are actually covered in ERA. So that's sort of is a second step. Now, EAG comes after you have some understanding of basic Python, and we want to convert, or we want to make sure that everything in LLM is considered as a black box. So we are not interested in going deeper inside what is reinforcement learning or what are attention mechanism and how LLMs are actually trained. The expectation in EAG is to actually make applications. That would mean that all LLMs are going to be black box for us. So we're not going to talk about how do we make an LLM better. We can do that in ERA. We cannot do that in MLO also. So EAG is about picking an LLM from, let's say, an open source community, or train ourselves if we are out from ERA. But assuming these are black boxes, then how do we create applications out of it? And EPI is focused purely on programming. It has a lot to do with AI side also, because we will have PyTorch sessions, but this will focus on making sure we understand how do we make APIs, SDKs, and have a much finer detailed understanding of Python. So it's pure Python based, Python and PyTorch. So when we are working on EAG, a bit of AI knowledge is required. That is something that we're going to cover in the course. When we are working on ERA, we need to know a bit of programming. Even though we have one session on Python and PyTorch, but this is going to be purely focused on understanding how do we make data sets, train a model, train it properly, what are the state of art, how do we do SFT, how do we do reinforcement learning, and then take a model up to a level where now we can go in production. This is where production comes in. Now we have online services that gives us a trained model, and they're hosted also. Now, if these two are available, then we can consider this as a black box and start applications which are related to EAG, RAG, or prompting, and make beautiful applications out. And if someone wants to purely focus on the fundamentals of programming, that's where Python comes in. I hope that gives you sort of an idea of what's happening.
Hi, Rohan.
Hi, go ahead.
Yeah, Rohan, hi. Hope you're doing well. Rohan, I wanted to if someone wants to understand the loss function of DC, would that be covered in this course, or we have to take some other course?
That will be covered in ERA.
Okay.
We in fact covered that in the last session. Last
Got it.
session.
So Rohan,
Hi, go ahead.
you able? So Rohan, so actually I'm interested in EAG and ERA. I have enrolled it for EAG,
Yeah.
but can I do ERA once I finish this EAG and then can jump into ERA?
You can do that, yes. As I said, for EAG to work, we're going to consider LLMs as black box, and from there we're going to
Got
proceed.
it. Okay, good. Thank you, Rohan.
Right, I've tried to make a lot of people contributors. Now I've made some set of slides, and I'll try and make sure you get some idea of what's happening, and that will probably give you some hint on why EAG and what is it that we're going to cover. Now, everything started from this paper. Paper came out in 2017, and prior to 2016, 2017 is when the paper came out, and this was based on the attention mechanism. Paper was called Attention is All You Need. But you're looking at two models at the same time. On the left-hand side, you have something called an encoder, and on the right-hand side, you have something called decoder. Now, today, the world is only focusing on decoder, but there are a lot of use cases for encoders also. So this architecture is the genesis of everything, but we have now simplified this into something that just looks like this, which is just decoder. And if you actually go back and forth, you're going to see that the decoder only architecture actually looks very similar to encoder only architecture. Now, the fastest way to understand an encoder versus decoder is going to be when we give an input to our LLMs, we're going to be sending a string. Let's say the string is I'm a good boy. So I am a good boy. In case of encoder, we'll have 1, 2, 3, 4, 5 inputs. We're going to add some fancy position embeddings, etc. to it. And then we'll have outputs. Now, outputs are also going to be 5 only. Right? So we have 5 inputs, 5 outputs in case of encoder. Now, what can we do? I am a good boy. Instead of good, let's say I do a spelling mistake. It can fix it. It can try and translate that in less than 5 or less than 5 words. It can try and summarize it also by saying something else, or maybe appending a token, additional token that can be said to be positive or negative, basically based on 0 and 1. Or it can actually create sort of a compressed embedding or a new definition or something that we can send to some other model. right? So 5 inputs and 5 outputs. So token number 0, 1, 2, 3, and 4 goes in, and 0, 1, 2, 3, 4, or some form of that comes out, right? So that's what we do in the encoder part. Now in the decoder part, we do something very similar. 5 inputs are going to go in, so we have 1, 2, 3, 4, 5, and only 5 outputs are going to come out. But we're going to send in 0, 1, 2, 3, and 4, and outputs are going to be 1, 2, 3, 4, and 5. So the way internally it works is if you had sent 0 only, then we are expecting it to predict 1. If you have sent 0 and 1, it's going to predict 1 and 2. Even though we just take 2 for the output, we don't care about this guy during inferencing, but while training we would have. And if you had sent 1, 0, 1, 2, 3, 4, then we are going to be taking this as the output, even though we are going to predict everything. So if you see encoder and decoder only architecture, exactly the same architecture. Only difference is we have 0, 1, 2, 3, 4 going in, and 0, 1, 2, 3, 4, a form of it coming out. And in case of decoder, we have 0, 1, 2, 3, 4 going in, but 1, 2, 3, 4, and 5 coming out. That's the actual pure difference in the decoder only architectures. Now, the reason this paper was special was because it solved one big problem where we had no solution for, and that was data labeling. We cannot sit and take every single word online and in books and annotate that, or try and figure out or convert it to some sort of data set that can be trained on. So they trained a model and came up with a new strategy where you just have to predict the next word, and that's an amazing thing to do if you think about it. For example, if I say I went to an Apple store to buy Ferrari, I need to say iPhone or iPod or something similar that's contextual. If I say Amit Shah and Modi are, right? So the next word that's going to come in, for you to be able to say that, you have to have a lot of context, a lot of historical knowledge, understanding that both of them are from same parties and so on. So just predicting the next word may sound very simple strategy, but it's like literally a genius of the strategy that I can think of. One of the few things I really like in machine learning world. So that's where this paper just changed everything. But after that, we had a lot of people experimenting decoder only, encoder only, decoder and encoder both, and so on. But finally, we have decoder only because now you can just start predicting the next things. We send in a set of words, and that can be the prompt we are sending to ChatGPT. So, what is my name? And I was going to convert that into something and give it back. Or if I ask, well, how's the weather in Bangalore today? Then you might have seen recently it actually goes online and does something. But if you ask a simple question, what's the capital of India? It's going to just respond back, capital of India is New Delhi. So it's acting in a specific way. This LLM is not that. That acting in a specific way comes after this. So here we're talking about pure base network. Here, in fact, I'm training an LLM as we speak. What these LLMs do at the base level is something like this. Here you're seeing a number, that's a loss that we're trying to figure out and try to reduce as much as possible, and some other things. But this is the, if I try and hide it. This is the prompt. So this is the text that's given in chapter 11, navigating anxiety through music therapy and imaginary rescripting. That's a text that's sent in and just continues from there. Have you ever felt really scared or anxious before taking a walk or playing a musical instrument and so on? So you see that it's just doing the completion part. So if you say, what is 2 plus 2? In fact, Andre Kapati has a really beautiful video where he actually showed this example also. If you just say, what is 2 plus 2? It's not going to say 4. It's going to say, what is 2 plus 2? It's a fundamental question of life. It can be 4, it can be 22, and so on. So it's just thinking in a way that it has to finish something, right? So when we train these LLMs, that's where they are. We are not training them to become a chatbot, right? So if you see here, if I come to our live space, welcome to our lives, imagine having a lemonade. So it just goes on in a direction where we are not asked to do something. It's just finishing up the next word based on the statistical data that it has. So that's what encoders are. That's where the base model, when we say GPT-3, GPT-4, this is what they are. They are not ChatGPT, right? GPT-4 and ChatGPT are different things. Now, this is what we are seeing right now. Once upon is the prediction. Then the is also now concatenated with our once upon, and then it's going to predict time. It's actually predicting upon a time, right? Always remember that, because it's going to be super useful if you're actually doing any course. So if we send once upon, the model has predicted upon and then R. So when we send once upon R, so we're sending 3 tokens, it's predicting upon R and then time. So 2 tokens go in, 2 come out. The task of each token inside a neural network, inside an LM, is to become the next token. So it's a very interesting insight if you think about it. We have sent 3 words. 3 words are going to come out. The task of each token is to become the next token. And that's why the masking and other things happen, because if I let this token see the next token, just going to copy it. That's where masking and other things are going to be required. But if we talk about this token, now this token is going to become the next token, this one, while looking at this token also, right? So it has access to all the previous tokens. But the objective of a LLM essentially is to convert the token number 1, 2, 3 into 2, 3, and 4. And that's how the loss functions and other things are configured. But again, not super useful. What will I do if I write LLM which finishes my story? I want it to interact with me and do something very specific. Now, before the new training strategies came in, we had hacks. In the last video, Kalpati also talks about this. You can sort of fake LLM into acting like a chatbot, but it's not going to be super helpful. And the way we do that is by giving you some examples. It's called zero-shot learning or zero-shot executions also. So we give it an example, classify this review, we give some sentence, and then we say sentiment positive. Then we classify this review, add some line, and then say sentiment. Now we're expecting it to say negative, but LLMs are designed to continue to just predict. So it might say negative and it might actually create its own example of classify this review and then actually give more sentiment and just continue. It's not super useful, but there were ways of playing around with them. After this came in SFT, which is supervised fine tuning. Now here we actually take Q&A kind of questions, and these Q&As are collected by humans and written by humans, and we now fine tune our LLM on top of this. Now the first model is called base model. These models are called instruct models. So they follow a very specific Q&A pattern. We learn how to we train the LLM how to be more helpful and answer in a specific format and such and such. Once that happens, then we have the next step where we have RLHF, where we further fine tune it to make sure that there is no slang involved, or I'm not talking about politically disturbing things, and I'm actually giving output that is useful, or I'm not saying I'm OpenAI, even though I might be some other model. So that's the final step that happens. So step 1, base model. Second model is instruct, and third model is specific fine tuning for. Now this fine tuning is happening in a lot of different ways. If you've heard of DeepSeek, they actually cracked one other part of RLHF where they force the model to actually do a chain of thought kind of thing, where it can think on itself. And new paper came out 5 days ago where they just append weight at the end of their at the end of the LLM, and LLM sees I respond this, and I responded weight also, and then it thinks again. So you can actually force an LLM to think about its output 3-4 times, and then finally concludes with something better. So here also, LLM is right now going inside its own memory and then giving you some output. That wasn't good enough. So what we did was we added something called RAG, where we get the query, we try and understand what that query is. Based on the query, we try and figure out what is the relevant data set I have, because everything may not be on the internet. For example, your emails are your own, or if you have documents in your company, then they're just going to be in your company server. And we need to go there, we need to figure out which document I can refer to as well, and then from there we give an answer. So first is LLM, where prompting is used a lot and we try and figure out a lot of stuff. Second is where we have RAG, where I can go inside my data set and get some information out. ChatGPT is already doing it. If you go online on ChatGPT and say, store my memory, so those documents actually become documents which the ChatGPT can refer. In fact, you can start a ChatGPT, have a long conversation, close it, open it next time, and open the same tab and continue talking. So ChatGPT takes that as a document, which now becomes a RAG actually, and refers to it and then continue talking. So you're already using RAG if you're using ChatGPT. But this also wasn't good enough, because what if I ask about something that happened yesterday? ChatGPT is going to come back and say that, okay, my knowledge cutoff was 24th of April, 2024, so I don't know anything about that. So why don't we add some sort of tools to it? Why can't we let ChatGPT go online and look at different things and new news and articles, and then come back to me? And that's where the agent comes in. So the version of ChatGPT we are using is already an agent. It can write code for you and execute it. It can set reminders for you. It can go online and do a lot of stuff. But only OpenAI gets to decide what this agent can do. So ChatGPT as an agent has few specific tools where it can do some stuff, but not apart from that. That's where the agentic AI, because now these are super easy to work on. The amount of training and data required for the first part, training a base model, is humongous. You may need around 20 trillion tokens and months of compute. The second stage of SFT is a one-day process, and the third stage of reinforcement learning is few hours of process. And converting something into an agent is actually super fast. It really depends on what use cases you want. So an agent is an LLM which is converted into an instruct LLM, maybe with the reinforcement learning as well, but it has access to a data set where it can get more information from and has some Python functions or online tools that it can use, right? So that's an agent essentially. And then we have multi-agents where you don't need one, but you need multiple agents. So we need some sort of a program called orchestration here, which is going to decide that I'm going to use agent A for this, B for that, C for D, and so on and so on. Now, there are a lot of use cases which we can think of where agents can be useful for us as normal humans. One can be smart scheduling, automatically pre-schedule meetings based on my wife is angry. Because if that's the case, then probably 4 or 5 years are gone. It needs to now go online, email, change calendar entries, maybe send WhatsApp messages also. All of that is now part of something that agents can do. Email management. Now it can actually read, summarize, draft, or even respond. In fact, you can say that if ICICI sends you email on some sales or there's a sales agent behind you, respond them back 1,000 times saying that I'm not interested. That's something you can do. There's automated note taking, especially when you're not listening at your home or in a meeting, where it not only takes a note, but it also does some action items where it summarizes, sends email, and maybe calls someone as well. There's expense tracking and budgeting. Is there a way for you to figure out how much money you've spent on Swiggy or Amazon in the last 4 or 5 years? Very difficult, but now something using agent, you can get access to your SMSs, your bank statements, and your application usage, and so many different things that you can actually figure out. Then you have task automation. You can actually, if you filed a property tax or a TDS, you know how complicated that is. That's something now you can actually ask your agent to not only follow up, log in, actually fill it up in 90 seconds also. There used to be a time when you had literally 90 seconds to fill in the TDS form before it would refresh, and it was a nightmare. It used to be 15 minutes, but it felt like 90 seconds. Then there's something called meal planner. For example, the most difficult question every day we have to answer thrice is "Maaj khane mein kya khao?" Especially if you're working, if you're at your home. Now that is something that maybe an agent can solve for you. Then we have smart home automation. If you think about it, at my home itself, I have a Bosch that can be automated. I have a Wiz, which is Philips bulbs and other things that I can automate. Then I have MI cameras. Then I have my washing machine, that is LG. Then I have my refrigerator, that is Samsung. And what else? I have MI bulbs also. And of course, you have iOS, Alexa, and all of that cannot work together. But now you can write an agent that can actually talk to all of them and actually synchronize it. Now you can actually make that Home Alone kind of movie where we have your enemy, your husband or wife coming into your house and you're scaring the hell out of them. So today, finally, it's possible using something like this. Then you have AI research agent. You can find the right car and right house that you may not want to buy, but just for the hell of it, sake of it, you can actually go on OLX and figure out the right car that you want to look at and not click on that website link that they keep adding as an ad. Then you have resume over optimization. When you are sending into some company, you can actually make sure you go online, figure out what that company is, or if you know the interviewer likes a particular thing, if maybe he's a Shastra Sangeet player, you can actually highlight if you also don't lie ever on your CV. Then we have shopping assistant, checking price on different websites and doing and calling a local store agent also at the same time, maybe WhatsApping him and asking him, hey, this is available at what price? Then we have social media manager. Now you can, just like a celebrity, get your social media managed by an agent AI that posts the best picture, best pose of you, and tell everyone that you also went to the Coldplay. Right? This is for normal humans. But then we have humans who are acting not normal. We have VCs. Finally, they get to respond to all the founders, understanding what their portfolio is and why they can't invest. When we are celebrities, they can actually monitor news, draft news, public statements, and unpack themselves for images they don't want. Lawyer, they can finally review and highlight key clauses just before the review meeting with the client. Analysts, they can detect emerging trends and make sure they follow those trends, so those trends are not trends anymore. We have financial advisor, they can track investment into companies and then suggest their advisee that these companies were wrong. Then journalists, they can fact check, decide not to use them. Politicians finally understand what policy changes were about and still not comment about them. We have software engineers, they're actually already using it. If you're using Cursor and other tools, then you're actually heavily using these agents. Event planning. Now, this is a very specific example. They can plan event, of course, but if you think about it, event planning requires sending RSVPs, sending right messages to everyone, making sure the seating arrangement is correct. You're not making a Congress person sitting next to BJP and so on, all of those messy things, following up on everyone who's supposed to come and deliver stuff on a particular, there's a lot of stuff that is required. And now agents can actually take that load. Then a teacher, you can actually personalize your review and your assignments also for students who are weak in a particular topic, and in others they may not be. UI UX, you can actually get critic directly by making these agents. Doctors, anything related to handwriting, except that they can also help. So if you think about what's happening here, we are not talking about super app. We are talking about a micro app. This is a micro app that solves a particular use case, and this use case might be so specific that you may not want to write an application for it, or even if you write, the use case might actually shift slightly, and then you're confused on what to do. And these are the things that are very dynamic in nature. You cannot write a program just for it. And that's where the AI agent is going to come in, where you have data coming from different sensors. Someone might be calling you. It can be a phone call. It can be a video call. It can be just a sensor data coming in. It can be a camera looking at a machine where the light just turns from red to green and then has to do something. And if it turns yellow, then it has to do something else. All of that program can actually be just embedded inside it. Think of it doing it from OpenCV perspective. If you do OpenCV, we're going to say if a red light flashes in a particular area, then area dependent, you can't do it. Then we have convolution neural network. If a red light comes in, then do something about it. But the problem there is, what if someone actually took a machine that had a red light in it and it will again fail? So you need something to actually take a call. No, that red light was not the red light of a machine with a backlight of something else. So that decision is something that now needs to be taken by an LLM, and an LLM can be actively taking that decision. Then we have cognition, which is where the decision making comes in, memory comes in, some rules, set of rules come in, and LLM has sort of a bit of common sense, and that common sense is super useful. In fact, it's actually way smarter than a human, but there are some things where LLM, you might think it's not really smart, but it's not that it's not smart. It was trained in such a way that it led to that answer. Now, finally, we have the most important step, that it can actually execute something, and that's where LLMs are very special compared to RAG. RAG can reach up to a conclusion. LLM agents can actually execute something, especially if you give it a Python black box or maybe on online tools. Not only can do that, it can write a code to execute something also, and that's also fascinating. Now, there's a good link which I'll refer to if you get time. I'm pasting this link on the chat just in case. The other use cases also mentioned here. For example, here we have a e-commerce use case, support. If you're not into e-commerce, you have no idea how weird the questions can come. Someone can say that I want to buy something which is now at discount at your store. I would like to return it. What do I do? Now, just generally, you'll have to do a refund, then you have to process again and all the stuff. But now, if you have an agentic AI, it can say, okay, let me just change your invoice value and refund you that particular amount, right? So there are a lot of optimization that can directly happen. Same in the healthcare point of view. If you want to apply for your life insurance, you better be ready for the amount of data that you have to push in. And even from the doctor and hospital perspective, there's a lot of work there. So a good example to understand how the big agentic AI systems are actually getting executed. So that was on that. And then we have these building blocks. Now on the building blocks, as a course, what we're going to focus on is this particular part. How do we create tools and make sure that agent can also create tools? Because this is sort of done as in we have a lot of expertise in the industry already and understanding how this can be done, but we are not going to rely on a particular library for this, because each library is going to make sure that they are the best ones. So okay, to help you understand, imagine today's 2016 and we have TensorFlow, we have PyTorch, and we have Keras, and we have Caffe. We are not going to get married to someone today. That's why we are going to actually look at all of them, but make sure we understand fundamentally what these are and write them on our own. And then there are other libraries that we can append to. We let the world decide which direction they're going to go. Today, there is no confidence on which one is going to go. And one of the big reasons for this is the agent can itself write a code, right? So we're not going to get married to any specific one. We'll be exposed to all of them. We'll understand how to use them, but write our own. Now, this is something that we're going to also include, and this is this later part of the course. And overall, when we include all of them, it's going to allow us to make different applications. So that's the overall objective of the course. And the syllabus is divided into 20 sessions. And even though I said that there's no background required, you need some background in LLM, and that's what I'm going to cover in the first session. Then we have some internals to understand how our prompts and other things are actually configured together. this is where we get introduction to agents, and then our actual development starts, where we look at tool use. This is the most important one, by the way. This is going to be the most important session, and if you are going to excel at this component, then you can actually make anything. All right, these are the first 10 sessions, and after that the next 10 sessions. Now I mentioned understanding browser based agents here, but if you see the star mark, and if you follow star somewhere else, we have a star here also. This is expandable to other apps and OS also. So even though we are saying browser, you can actually implement it on your mobile phone, working at an operating system level, or Linux, or wherever you want. But we're going to focus on browser based because a lot of tools are available, and you all have browsers, but you may be working on a particular distro of Linux, I may be on Mac, and somebody else might be on Windows. So we don't want to enter in that field, but exactly the same can be implemented anywhere. Okay. And finally, we have this capstone. Now, this capstone is going to be an autonomous browser or something else agent. That's going to be your task. We're going to give you something that is super difficult and tricky, and that's something that has to be solved using this particular part. So once this is done, then you'll realize that you can actually build anything. And that's the whole point of the course also, that AI finally is going to help us build things. And that's the end of the session. So then I have some marketing material about School of AI. I'm not going to go into that. Now I'm open to any question that you may have. How many hours should be invested every week for EAG? I'll recommend at least 6 to 10 hours, depending on how much you understood in the session. If you did not understand a lot in the session, then recommend to spend more. Now, the way, there's something that I like all of you to realize, understand, and appreciate. Any topic that we have to learn can be divided into 3 things. First is what, second is how, and third is why. Right? What is attention, for example? So most of the topics need to end here, knowing what they are about. Then you need to go into how. And in how, we are going to understand how does attention work. And third one is going to be, for very, very few topics, that's why attention works. And the reason is very simple. Amount of time we have and amount of things that we need to learn, they are not same. You don't even have time to cover one topic in detail. Every topic can be a PhD topic also. So we need to figure out which topic we need to understand, what about, how about, and why about. Now, what is going to be most of our topics? Now, you're going to see if a topic has existed for some time and there's no development on top of it, that means it's sort of SOTA and that's a fundamental topic. Then you're going to go into the how part. But only if you realize that the topic is super critical for you to build something on top, then you're going to go into what part. If you divide your learning schedule into something like this, then you'll see that it's actually easier to move past things. For example, there's something called Fourier transform. What exactly Fourier transform does is something that falls into what? So I need to know that. How does it work? You will have to spend around 6 months to understand how does it work, if you really want to go into pure detail. And after that, why does it work is a philosophical question altogether. So there are topics that you can actually avoid and convert into black box. This is black boxing basically. You know, make sure that you have understood that this particular topic can be black boxed. Very good example. For example, we have RAG. You have heard of it, right? And immediately after some time, some few months back, came CAG. So should I leave everything and start learning what is CAG? But after CAG, we again already have developments on top of it. I can't just keep on learning this and this and this and this. So every single topic, if I keep on learning, I'll just be on the learning route and never make something. So you need to commit yourself to, let's say, okay, I'm going to be obsolete from the SOTA point of view. I'll understand RAG properly. I'll implement that. When we are in production, or when we actually get money, then I'm going to look at what is the state of art and then actually implement that part. That's the best way to learn. So to be able to do something of what I said, you need to make sure you have at least 5 to 10 hours of week apart from the class. All right, what can we done in the next one to help us? Okay, so I shared 3 links on our Telegram channel. One is a Python 1-hour lecture. That's the base. Continue forward if you have time. Second is going to be Git. We're going to be using a lot of Git. You need to use a lot of Git. So you need to be comfortable with what Git is. And third is a small series from 3 blue, 1 brown. That guy has an amazing voice and he explains in a very well way also what neural networks are. So it's going to be really good for you to understand what neural networks are from his point of view and why to do work. If you have some base understanding, because if you keep asking me why does it work, the problem is the answer to a question like why needs a lot of time. So you need to have a bit of leap of faith while you're driving. For example, you are driving your car for the first time. What is the question you should ask? Most of the question need to be on the where side. Where is the accelerator? Where is the brake? If you ask your teacher at that time that why does the accelerator work while you're driving, it's going to be slightly complicated to drive. So that's how you need to divide your learning schedule out also. And that will make sure that you have enough exposure on what to understand how, and enough exposure on how to understand why. Now, the examples I gave on the agents are all it's sort of examples which I wanted you to have some relation with, but the real example is actually automating something that is happening in your company or something is happening around you. So anything actually can be converted into an agent, and you're going to see that you need to figure out the right use case for it and make sure that it's implemented properly. And that's where we are seeing a lot of people moving in the agentic world already. ChatGPT is a very beautiful example. When did it became from a chat GPT or an instruct GTP to an agent? Nobody even knows about it, right? They just peacefully launched, okay, we are adding scheduling. It's all agent. So you need to realize that everyone is actually going towards agent without telling you. Will you talk about how reasoning models work? How is the training done? Answer is no. That is going into the direction of ERA. Right? So that is ERA. So ERA is knowing why neural networks work and how do we make it better. And EAG is about how do we make applications out of it? How do we make agentic AI applications from the LLM that are already trained? How many hours each lecture on Saturday? So the way it works is this session is going to be 2 hours. Some questions interceded in between from students, say 2.5 hours, but then it may extend up to 3.5 hours also, because I don't end a session unless all the questions are answered. So if somebody has a question, and generally many students will have their right thumb getting married to the left thumb of somebody else, and they would have skipped the last session, so they'll have a fundamental question which I'll rather answer now, because this is the only way to interact between us, right? Otherwise, there are a lot of courses online. You can go there and learn from them also. But this to and fro is something that is very important. So the first 2 hours is sort of compulsory. I can't force you anyways. And the next 1 hour is sort of optional. But I'll recommend that you listen to all Q&As, because there's something I love to say. If you have a stupid question and you don't ask that stupid question, you remain stupid. So let's not do that. No question is stupid. Other people will also have similar questions. And if your knowledge is based on, or your foundation is being built on questions not answered, the foundation is going to be very weak. Ask anything from grounds up. In the 20th session, ask question about session 1. I may get irritated, but I will still answer it to make sure that you get exactly what is required to understand something. It's very, very important. We don't have questions related to what we're learning left. So that's why it might actually extend to 4 hours also. What access do we need, like OpenAI? You don't need any specific access. You're going to go to Google. It's called Google Gemini Studio. Yes, yeah, Studio. Yeah. I'm not signed in, but after I sign in, there's I'm using my computer for like 5 years now, but I still have to tell my computer that. Yeah, just sign in. Okay. Yes, so we're going to be using Gemini Flash. It's really good, and because Google is behind, they have given it free. So what you're going to do is you're going to go to API key and actually generate a key for yourself. That's what we're going to do. You'll need LMS access. This is how the LMS is going to look like, and you will not see ERA. You will see EAG. On the left hand side, you will have assignments, quizzes, pages, discussions, and so on. And on the right hand side, this box will talk about the sessions that we have. Each session will have a content. It'll have assignment and a quiz. Quiz is sometimes there, sometimes not there. Each assignment page will have details, and this is exactly what I'll be covering in each of the class also. So here you'll see there's some text, some videos, and some stuff. And at the end of each page, you're going to find 2 videos. One video is going to be the studio video, and second is going to be the Google Meet video. Some people prefer Google Meet, some people prefer Studio, so we add both of them. And there's going to be transcripts also sometimes next to sessions also. If you go on the assignment page, it's going to look like this, and you are going to see it differently. I'm seeing as a teacher, I'll have a student view where it will say attempt, and then you attempt, you'll have some time limit for it, maybe some score for it. A quiz will have a time limit, for example, and it's going to be graded. Now, the way the assignment score works is that either be like Hercules, do not attempt any assignment, any quiz, attempt the capstone and deliver the best capstone, then no assignment score is required. Or act like normal human where you are continuously practicing also, submit assignments, make sure you have at least 60% score, and submit a normal okay-ish capstone project. That's how you get a completion certificate. There are only two certificates that we provide: participation certificate, and that's for someone who has attempted even first lecture, not even submission, and completion certificate, which says that you actually finished the capstone and maintain a 60% score. Your certificate will not mention any score also. So even if you are scoring 40,000 out of 10,000, which is possible, we don't mention that in the certificate. Now, I don't know why people want certificate, because I personally, when I hire, I don't look at certificates, but we do it because people want it. This is not Stanford, where you can go and say, like, I finished something on Stanford. It's a very niche group where only people in School of AI know you were at School of AI. So, but we still do certificates because people want it. All right, anything else? Can I recommend any course that is a beginner level or does not know too much technical programming prerequisite? No, all the courses that we have are at beginner level. Even EAG right now, the amount of Python I'm expecting from you is not much, but the learning curve is steep. Out of 100 people who start the course, not more than 40 are there in the last session. Please keep that in mind, because this is the hardest of the hard course that is there. It's not hard because I am not good at teaching. I'm really good at teaching. It's hard because contributing the 3 hour and then followed by the 6 hour and 10 hours to 14 hours every week continuously for 6 months for EAG, and these ERA courses are 9 months long. Doing it for 9 months long is difficult. You know how many classes you miss in your own college, right? That's why the course becomes difficult. The content is beautiful, your group is going to be beautiful, but amount of time required or dedication required is hard. And things are moving so fast that if you are planning that you're going to take it slow, then by the time you finish something slow, things would have moved. So you need to keep two things in mind. One is, what is your career trajectory? If your career trajectory is in programming and in making apps, right, then you have tools like Cursor already, and we have this agentic AI that is sitting waiting to replace you. So you need to make sure that you can actually make it agentic AI. And second is, you're starting a career and you are going to focus more on the fundamental side. That's where you need the Python very, very deep understanding. You also need Python deep understanding if you're not an application side, but providing SDK side, or you're providing APIs, right? What are you providing? You're providing applications, or you're providing services. If you're doing on the services side, then we have EPAI. If you're on the applications, then we have EAG or MLO. If you're on the fundamental side, where you really want to become someone who knows how to train models and actually be at the edge of it, then we have ERA. So following my own career guideline, I will actually do something like this one. We have EAG basically, because I want to make sure that I'm relevant. Second, or MLO, depending on I'm DevOps side or I'm on the application side. Then we have EPI. That is something I will actually either do at School of AI or I'll find something else also online. There are a lot of good Python courses on Udemy, and consistently spend my time. So I'm not recommending EPI. In fact, I'm saying that find some course online on Python that you do continuously every week or every month. Be disciplined about that. And then I'll definitely do ERA if I want to focus on the research side. I want to understand how do I train my model. The world is divided in two parts. We have consumers, which are going to consume the LLMs, and then we have producers. We need to be on the producer side as a nation, but unfortunately we do not have resources. Fortunately, the training cost and other resources is falling down, so we can do something like this. But if you're on the revenue side, then we need to make sure that we know how to use AI also. So when you write EAG is equals to ERA plus EPAI. That's not true. This is not there at all. Here you can say Hugging Face actually. We're going to be taking everything from Hugging Face or Google Gemini. So EAG is going to be this, and EPI also not. EPI is going deeper into Python. EPI is, if you actually do EPI, you can write your own programming language. That's how it goes into the Python. That's how much it goes into Python. EAG is about Hugging Face plus your programming knowledge. And that can be in Python, that can be in something else, where we actually use both of them to make apps. Now, if you want to scale these apps, then you need MLO. Or you can read online about one specific use case and scale that application to massive levels. So what would you recommend someone with the AI product manager career trajectory? If you're in the on the product manager side, then EAG and MLO. MLO is going to tell you how do we scale up, how do we do massive scale deployments or save cost. And EAG is going to tell you how do we actually make applications which are based on LLMs. Remember, LLMs have 3 applications. One is prompting. That's something we're using with ChatGPT. Then we have something called RAGs or CAGs, where we have our company datasets also included. This is where the company use cases start. And after that, we have agents that build on CAG, but now can take some action also. Now, what new content will be added to Era V4 related to agents, etc., compared to current syllabus? Okay, now let's look at Era here, okay? And if you focus on the content that we're covering. So here, from here to here to here, all of this is convolution neural network, right? So 9 sessions dedicated to that. And after that, if you go further, you're going to see from session number 10 till here. Here we end up learning how do we train a transformer or LLM and sort of SFT. We are started to hit the SFT side here. So that's sort of 20 sessions. And after that, if we now go till here, we finish our SFT. After that, we have 1 session on RAG, 1 session of MLOps. Then we talk about edge deployment, again, cloud, and coding exercise, reinforcement learning. And this is one of the last components of SFT, and then end-to-end project deployment. So if you see that we are actually not going into agentic side at all, we have 1 session understanding what agents are. We have 1 session understanding what RAGs are. And then we have actually 3 sessions based on reinforcement learning. This is RLHF or DPO or PPO side, right? So there is nothing on the agentic side except for 1 session or 2 sessions to understand how do we actually go in that direction. So it's not going to go as deep as EAG, which is 20 sessions long. Kevin, go ahead.
So, like, who would be teaching these lectures? Would it be you, or like how would those go
It will
about?
be me. It will be me if you.
So, can you hear me?
I can hear you. Can you hear me?
Yeah, yeah.
I will be
So,
teaching. Yes.
okay, great. Thank you.
Okay, what kind of work we will be doing in industry if we take Era? How is the demand right now? Okay, so it is expected that around 80% of jobs are going to be automated. So either you can wait for that automation to take away your job or be part of the automation team that is going to make that happen. So that's where things are going to be. Now, second is if your company is not into data management, if for example, you're into mechanical engineering right now, or you're into providing some sort of services. So either you are on the part where you're interacting with customers or dealing with the deployment side for something that is already done. There you have a specific role and you're doing that role. Slowly at the back of the industry, someone is automating that part already. So that's a call that you have to take from your own career trajectory, that where do you want to be? You want to be on the automation side where you can actually make a job faster, transparent, and better. Of course, at the loss of some jobs that are going to also come into picture. Or you want to be at this particular front where somebody's going to automate your job and you're just gone. So I specifically do not know your industry, so I can't answer to your industry, but you need to understand that these are the only two things that are going to be there. How's the demand right now? Everyone wants to use agentic AI. There's a lot of hype that has already started. People don't know how to use them. So, and the same thing has happened on LLM also. A lot of hype. 2016, moment ChatGPT came in 2022, extreme hype. And if you see that, where did all the hype and money went? That went into US, and then from there, France for Anthropic and other part. Now China is coming up. India is just lost behind. So same thing is going to happen on the agent also. On the agentic AI, US has already taken a lot of lead, and Europe and China is also now following them, and India is already behind. So again, we can decide from our own career and nation trajectory that we want to lead this particular domain, or we just want to use somebody else's library. For example, PyTorch, Keras, Cafe, TensorFlow, and many, many more. None of them have any origin from this country. Now, one of the part of EAG, what we're trying to do is to sort of write so many different tools, and that's going to be our assignments, to make sure that anyone who wants to write an agentic AI ends up using our library, right? Where they want to convert a PDF into a black theme PDF, here is a tool for that. They want to connect to WhatsApp and message someone, here's a library for that. They want to understand Swiggy email, here's a library for that. So we are going to make sure that we have so many tools that we are not left behind, especially finally on this final frontier. Agentic AI is the final frontier. There is no AI after this, because agentic AI is sort of precursor to AGI, and AGI is not going to be, even if you think about it, AGI is not going to be so smart that it can actually calculate Fourier transform components for any equation. It was still going to use a calculator. Agentic AI is that. LLMs are going to become on the smarter front, but ultimately it's all going to be agentic framework which is going to use them. In EAG, will we be doing any model fine-tuning from Hugging Face? Answer is yes and no. There are two parts to it. One is we are not going to do model fine-tuning. Model fine-tuning goes to ERA. Here we are going to be doing something on the fine-tuning of a few other models that we're going to write. These are the models that are going to decide what to do. See, think of it like this. Let's say our agent is talking to Frank. Frank happens to be from US, and he has another user, and this user is called Alok, and this user is based out of India. Now both of them ask question, what is the temperature right now? Now to Frank, it needs to answer, let's say, in Fahrenheit, but to Alok, it needs to answer in Celsius. And for both of them, we have different function for some reason. So we have a function called def current underscore temperature underscore Celsius, and similarly underscore F. So now our agent needs to decide which function to call for which user. Now we can hard code this. This is where the course will start, that based on this, call this function, based on this, call this function. But then we need, again, you're going to see that this is limited. So we are going to train a small model that based on the input will decide which tool to call. This is essentially a function tool process. And this is something that we are going to be creating model for, and using reinforcement learning will train these small models. But the models trained here are going to be very small compared to the large billion parameter models. Not specific to the course, but want to know your thoughts on software engineering jobs. Do you think we would be seeing percentage job loss? My prediction is 80%. 80% job loss in next 5 years. When I say job loss, I also want to explain what this means. I'm not saying 100 jobs are going to become 20. If 100 jobs were to become 500 by in next 5 years, I'm saying that won't happen. That will remain 100. So if you see from this perspective, we've lost 80% of jobs. That's what I'm saying. This also means
just to follow up,
this also means there's going to be a lot of what's the word, when two companies combine, what is it called, consolidation. Sorry, there's going to be a lot of consolidation. Right now, if you think about it, we have a senior manager, then we have a program manager or a product manager. He has a senior engineer, then you have senior engineer 2. If you're on Samsung, there you know SE 2 and 3 and so on. Then you have junior engineer and so on and so on. That's how teams sort of look like. Maybe he has another senior engineer for deployment. All of this is going to get consolidated. They are expected to form their end-to-end understanding, and then this is going to get consolidated, then this is going to get consolidated. And program managers who can actually do everything end to end is going to be in need, and that's where agents are going to come in. Because when you have 10 years of experience, you're not expecting to sit for hours and write a code, right? A code would have been submitted to by a junior engineer, so why don't we take it from an agentic AI? That's how you're going to think. If somebody else was to deploy this particular code, why don't I get an agent to deploy it? I will just review it. So most of the jobs are going to go inside the review side. In fact, there is this Simon Wilson. I'll recommend you read him every day, and he mentioned something that is better than what I explained. Yes. Read this part. The future belongs to idea guys who can just do things. Jeffrey Huntler with a provocative take on AI. I seriously can't see a path forward where majority of software engineers are doing artisanal handcrafted commits by as soon as the end of 2026. He's saying 26, I'm saying 2030. 2030 because we're in India, we have Infosys, Wipro, and they can't just fire everyone as well. Then we have the calls for companies, etc. It's hackathon, blah, blah. But look at the last line. If you're a high agency person, there's never been a better time to be alive. You know what is the meaning of high agency? Anyone?
No.
It's a British way probably of saying smart or smart ass or intelligent or street smart, or saying that you really know what you're doing. Kevin, go ahead.
So, okay, so just adding onto that thing like that you mentioned, like 80% job loss. So that's scary, right? So what happens, right? Would there be like a subsequent job creation, or like what happens? Like, yeah, even if you learn about ALML and like how to create or write software using ALML, like what does that mean?
Okay, so I'll show you a very small example of this. Okay, let me go here, click on Q&A, and I have something called Speed Reader. Now, the way this LMS is configured is that I have to open every student, see all the things that this guy has submitted. There's a YouTube video, then go here and then go here. I have 370 students. For each one of them, I have to go inside this box and click. I can't tell you how much time this takes compared to just reviewing the assignment. So I thought, why don't I actually make a tool for that? I made this tool and I click scan. It scans all the points for me and I can score here while I'm reading here. And this is not the version I use. My version is on my other desktop. It actually gives me links also, so I can directly open my links. And once everything is done, I can click on something called sum up. When I click sum up, it goes through 370 links, extracts the answer, stores in a HTML and downloads for me. Then I can upload it back for my students and they can understand what how much any student scored. So why I'm showing you this is because this tool is very, very specific to my requirement. There are going to be companies that will need tools which are very, very specific to those requirements. Now, we needed 5-6 people to fill in that requirement. So when you write such tools, those jobs are gone, right? So these are unnecessary jobs that were there because of inefficiencies first. Second, there are going to be many few people who will know how agentic AI works. Not that everybody can't learn, but they would have learned earlier. So people who have learned earlier, they're going to be making these tools and they're going to be super relevant. And new job creations are going to be now for the new kind of problems, right? Humans are creative. We can come up with, if you're married, you know what I'm talking about. You or your partner can come up with a problem that now needs to be solved. It wasn't a problem yesterday. So humans are very creative from that point of view. We will figure out a new domain where we can implement our skills, but the skills as we know of today are not going to be useful at all.
Yeah, which is interesting because I was thinking about like how the industry shifted from desktop applications to cloud, but that shift was gradual. But this wave is just hitting much harder.
They're going to be much harder. A very, very interesting example. For example, the moment the UPI came in, the companies that lost a lot was the small toffee companies. And it suddenly, okay, yeah, makes so much sense. So we really actually can't predict which kind of jobs are going to go. But my hunch says that the software jobs where we're doing a repetitive, boring work or any pipeline that is, in fact, in my own company, The reason I'm super curious about this particular course myself is because in my own company, there are a few jobs that I think are like just stupid at the core. We have to do it because there's no way to automate them. Because every single decision needs to be taken by a human. We can't just take a decision there. We don't have a set of rules that can be implemented. And there are many, many jobs like that. So all of the jobs are just going to be rushed away moment we have something like this. We'll have people who will sit on them, make sure that these are working properly, but they'll not be responsible for actually executing those things.
Okay. Yeah, so essentially the time is like next 2 years to essentially like 1 year, 2 year to essentially switch and learn ML, AI, and how things are working in order to be at the forefront. If it's longer, then potentially it's a risk, I believe.
And the forefront changes so fast that it's really impossible to even follow. I just showed this to my students in the morning session and just want to open that. Yes. Now, this is an AI generated video. I really have no words for something that's now coming out. It's not only good, it's so good that I hate the fact that this is actually how we speak.
Yeah, this is scary.
And this is lip sync with the body pose and other stuff, and there are some other demos also for. That's how fast the forefront is moving. So now think of it like this. Now I had an interesting call with the largest gaming developer in the world. They are, I think, sending 3/4 of their students to attend the course also. They were asking that, has anyone made an agentic AI for UI, UX, and the animations and graphics? And the answer is, of course, I don't know, and possibly, but you can see here, this has such a high use case for gaming industry also. But the question instead they should have been asking is like, how do we actually use agentic AI and actually solve the use case before other people start solving it, right? Because many people have tried to be an alternative of, for example, PowerPoint. I don't know if you remember Prezi. I was a fan of Prezi when it came out. It just disappeared. One of the best platforms. I thought that okay, finally we have something that is going to kill PowerPoint, but it didn't scale up. What scaled up instead is something called Canva. Canva is like $1 billion company now, so we need to be sure that not only we understand what's coming up, but how do we think creatively around that to make these applications beautiful.
Yeah, thanks for sharing these insights. This is useful. Thank you.
I have enrolled in EAG. I had done ERA V1 in past. Will console also updated includes the latest module. I also plan to go through once. Yeah, so ERA V1, whatever you covered is good enough for you to cover EAG. The old ERA content will not be upgraded. That's a lot of work. And I'm making others also contributors now. So in case you also have questions, then. What about the jobs related to creating and maintaining AI infrastructure? That's MLO, and those are going to be there. Again, the number of jobs will reduce there as well, but they are going to be there for long because that's an expensive. Those are expensive mistakes to do. If you are MLOps engineer and you screw up, your company will have a big bill. So again, oversight engineers are still going to be there, but actual review or maintenance engineers are going to be.
Hello, Robin. Hey, hi, Robin. I'm Rajesh. Like, I have been part of your initial ERA and those courses. I was a data scientist that time, but then I moved into MLOps engineer and now focusing on pipelines, infra, Docker, Kubernetes. But I still keep myself updated with all these things happening in this LLM field and even agentic AI as well, Robin. But I'm not.
Remember you, Rajesh.
Thank you, Rogan. Yeah, Rogan, do you suggest me to take up this EAG because I'm into MLOps and I'm just whatever these data scientists work, I'll build the infra for them. applications for them to take it to production. Do you recommend this course for me, Ruben?
See, it might sound like I'm marketing EAG, but if you're not doing EAG, then learn agents somewhere. Because
Okay.
if you're not learning agents, then you'll be gone within a year, believe me. Agents are, uh, I just told you, right? In my own company, there are like 5 core engineers, and I see how agents can eventually replace them within a couple of years. Do I want to replace
Okay.
them? No. Will I end up replacing them? I actually don't know. It's possible
Okay.
that I may actually want them to be promoted to something where they can supervise, because they are very smart, intelligent engineers, right? And they're best students of School of AI, by the way. And I don't want them to be coming to office at 9:30 or 9 a.m. and then work till midnight and solve a problem. What if then an agent can be made that can actually help accelerate what they're doing, and why don't they actually make that agent itself? So that's
Okay.
how most of the companies are going to go in the direction. And the point is, think of a simple example. Let's say a new library comes in, and in a board meeting or a manager meeting, you discuss that we need to update that library. Just a one-liner statement, but now we have no predictability on amount of time it's going to take.
Mm-hmm.
Now, moment that kind of thing comes in, and you take an agentic, now you can actually throw a compute on it, and you can actually compress time, where it goes to every single line and make sure that change is done, tests is properly, and there's as less uh, mistake as possible. So
Yeah, that's correct, Rogan. Like, even I saw some video like 1 week back, and they are assigning a GitHub issue to the agent, and it just solved in a minute. So
exactly.
that looks scary. But since I'm in a different field, not completely on developing an LLM, so wanted to get your
See,
suggestion,
if the
Rogan.
tsunami can't cross the mountain, the flooding will. Maybe you're safe for some time, but not a
Okay,
lot.
got it, Rogan. Yeah, sure. Thanks,
Yes.
Rogan.
Thanks. Simon, yes, Simon. By the way, I spend a lot of time on Simon every day. I try and make sure I read this guy. Can you share the link? Okay, my query is I have 12 years experience in wireless telecom domain, currently working 5G, 6G, embedded multi-core, so I cannot position myself in the new engineering world and say relevant and how EAG. Okay, so Pankaj, the way you have to think is what is it that you're doing? Okay, and if you were to make an AI do exactly what you're doing, what would it do? And then make an agentic AI for that. Anything that you're doing right now, you can think, you can tell yourself, okay, I have so much knowledge about the electronics that AI can't meet. Not true. I have so much knowledge about my company products that AI can't meet. RAG. Then you say, okay, I know about my what is it that the new product that we are working on. I can understand all the framework and the new requirements. Agents can't RAG, but agent can't make it. Agent AI can actually make it. So the way I have to think about this is the work that you're doing, divide that work into small components and then see that can an AI actually do it. And if you think that AI can actually do it, not today, even in a year from now, because you're going to be ready in 6 months, even if you do this course, then actually take this course and make sure that AI, you know how to use AI to fix or make that job possible. If you think you're in a job where it's not going to affect and it's going to be sustained for long, then you don't need to know this. Now, would I recommend ERA or EAG for someone like you? I'll recommend EAG for you, because for you to know how LLM works is not going to be super useful unless you are training an LLM to actually make a chip, which is what Google has started doing, right? So fundamentally, in their case, they need to understand how the LLMs work, how do we make tokenizer for a circuit design in that case, and then actually make an AI build a circuit board for me, or maybe a small IC for me. It really depends on what your job profile is. So if you're into making fundamental chips, fundamental ICs, fundamental frameworks, and then you want to use AI, then you need to be in the uh, ERA framework. Which agentic framework will be used? As I said earlier, also, we're going to use all, and we're not going to depend on all. We're going to, we have slight preference towards small agent because of one particular thing. And I relate to that concept, and that's why. They had a paper, which is somewhere here. Okay, so instead of taking more of your time, launch a blog post. Yes. This image. It's a boring image. I agree. Okay, it's a boring image, but what it's trying to show you is agent can work in two ways. Either it can create JSON or text-based actions, or it can actually write code for that particular action. And this has been shown to be fundamentally far superior compared to just write actions in text. So less code required, less tokens required, much better, because there are ways in which you can define things that is very difficult to explain in text, right? For example, if you have to say how much I love you to your wife or your girlfriend and you have to describe it, versus if you say infinity, this is easier. So on the coding side, things become slightly more easier compared to actually pinpointing and specifying in this particular format. And small agent is on this direction. And I feel that if our agents can themselves write a piece of code, then our implementation is very similar to small agent. That's what we are going to be slightly inclined towards, but we are going to look at Crew AI, LangChain, and others also, because they have also written beautiful tool chains and functions which we might actually import, or your company might end up using LangChain or Crew AI, so you need to know about them also. Any automation examples in mechanical design, process meshing? So we ourselves are doing in our own company. We have just started to think about that. But as of now, I don't see any outside use case, so I can't refer to something, but that's something that exactly what we are building internally. Will we go evaluation of agents? Yes, we will have some notes on it, especially because we are always going to be, see, our course is sort of advanced. If before the next class, if a paper is released, one of the things that I make sure is that I try and cover that paper. So, and papers will definitely cover evaluation. So yes, we will cover. So is agentic AI all about LLMs, or they would be language plus vision models? If you have joined late, then it's fine. Otherwise, okay. Agents can take data from camera, vision, text, audio, or sensors. So we don't care about LLM now. LLMs are multimodal already, so it can take any kind of data. What kind of tech stack will not be in use as agentic AI progresses? Dhanush, I didn't understand your question. Will the course cover desktop application automation if there's no specific API access? We will cover something on the compute use, yes, computer use. Do you suggest to read any paper on agentic AI? I recommend. So I shared this one paper on Telegram in the queries section also. So if you access that to read it. Go ahead, Santosh.
Yes, Rohan. So my question is, will we be using PyTorch extensively in order to train smaller models, or any tool similar to PyTorch?
We
Like,
will
what expertise do we need
not much.
for
If you know Python,
PyTorch and
no.
Keras?
If you know Python already, you already know PyTorch. It's just about knowing few additional things, and the amount of code that you're going to be writing is not much. It's probably 100 lines of code. It's what happens after that. So most of the agentic AI work is going to be on the Python end, and PyTorch will be required for training some of the models. And that code is also very limited. So you do not need extensive knowledge on what is happening inside these PyTorch libraries.
Okay, got it.
For example, I'm training this particular code, and unless I show you the model, which is this one, everything else is something that you can understand. So if you go here, all of this is print, output, print, if, else, all of this is normal. There's nothing special about it, but this is the training code, right? And if you look at the inferencing code, that's going to be even simpler. So not much there. So if I don't tell you this PyTorch and you see model train, simple. Epoch, if you know what these words are something that you're going to get exposed to. Epoch is training through one single data set once. So wherever required, we're going to cover that particular part, but it's not going to be much.
Thanks.
Okay, for a beginner to industry, will EAG be relevant even if we have enough prerequisite? Okay, agent is at the same location where we had ChatGPT when it came out. So you need to make a call whether you need to be at the forefront of what is happening in technology. And also please remember, by the time the course will end, we'll be 6 months into the 2025 further. So we're talking about ending somewhere in July. So from February to July or August, a lot is going to happen. And agentic frameworks are going to be just bombastic on top of us. So if you know what is happening in that particular field and you can adopt faster, I recommend that. Otherwise, we can wait for seeing how specific industry is reacting to somebody and then wait for it. Now, if you're a beginner in an industry and you already are aware of how agentic AI work, then okay, so let me show you a very interesting snippet. Okay, this is coming straight from our. This is a career channel. Okay, this guy has posted, "I'm looking for a LLM agent expert to recruit immediately. Please DM me if anyone's interested, and I'll share the job description." No response. Right, people are already seeking such people, and I have another group where there are 6-7 people who are already looking for something, looking to hire people on agentic side, but they just can't because people don't exist yet. Shubham, can you come on the mic and ask that question again?
Yeah, hi Rohan.
Yeah.
Rohan, so like in Python codes also, we are building kind of agent application as a capstone project.
You're
So-
you know you're in Era also.
Yes.
You know difference between MNIST and ImageNet dataset.
Yes, I know.
That's the difference. You have one, and I've not even taught you in EPI. There you're writing as function where you can call 2 different functions. Here we're talking about a lot of different things. Way more exhaustive.
That's good analogy. Thank you.
Yes, it's way more deeper compared to whatever.
Mainly like on tool calling side that you mentioned, which is very
Not
important
only
part
tool
of.
calling side, it's going to be how do we plan? What is the architecture? Where is the memory going to be stored? How do we make sure the context is there? How do we do state management if something restarts? How do we handle external APIs? APIs written in JavaScript or maybe C++? How do we use reinforcement learning to learn from mistakes and actually make it better? In case of RAGs, how do we make sure that we can go inside our data set, and when we add a data set, we make sure that that updated information is also taken care. Then how do we go on the browser side and star goes back to the down, basically on the overall OS side. Now, how do we parse something? Because parsing this page itself, let's say if I open this page and you right click, inspect, this is the code that's there. We can't send this to LLM. Look at what you see and look at what we'll be sending to LLM. Right?
Got it.
Massive difference there itself. So how do we handle that part? Then how do we interpret the goal interpretation? Intelligent goal interpretation. How do we make sure the LLM knows it has fixed something or done something? Then we have multi-agent systems. One is working on browser, other is working on OS, other is working with sensors, the other is getting a camera input. And how do we interact with among all of them? And 19.1 is actually overall task orchestration. How do we end-to-end handle something which is linked together? Each one of them solves a specific problem. So it's much deeper compared to your capstone there.
Got it. Thank you.
Will web development full stack roles be going to end due to AI? I don't know. What I can for sure say is that a lot of jobs will be gone in that domain, and the jobs that are going to be there they're going to be using tools like Cursor and advanced version of Cursor agent or their own agentic AIs to make sure that 5 of those jobs are not required, only 1 is required. That's what I see. So if you say front-end job will be gone, answer is no. But we'll have a front-end engineer who knows how to use agentic AI to speed up his output. That's where I think either more jobs will not be created or jobs will be lost. How will we learn how to use Cursor in EAG? Answer is yes. You'll actually be dependent on Cursor a lot. A lot of code will be written by Cursor for us. Any views on the future of big data? Oh, so I have a very biased opinion on this. Whenever anyone say big data or any similar word, I just think of it like it's a very specialized field where they're trying to maintain or control resources or use case of a lot of resources or some optimization. That's the only exposure I have. I explained in the beginning, right? There's what, how, and why. That's the only thing I understand about what and on data science, and just my information just ends there. Because if you see LLM is a compression of every single unit of information we can find online. So if you talk about big data, that is already compressed into an LLM. If you talk about getting very factual and correct information, then we have something like RAG from where I can pick information. So I don't see a use case where the data science and big data fields are going to continue to exist unless it's very corporate-ish and the information is so banal that we do not want to use LLM. For example, the DNA data for every single, or maybe a billion humans. Now, in that case, I don't know how do we feed that to LLM yet, but there's going to be time when that will also be fed to LLM, and LLM can also understand that, okay, you have a very specific gene that makes you ask some questions. So that's my view on big data. It's going to finally merge with LLMs because big data is, for me, a hard drive and LLMs are like processors. So we have to link them, and somehow that is taking longer than I expected. The session recording link post session we shared. Yeah, I will share the uploaded YouTube video on the Telegram group.
Hi, Rahul.
Hi.
Yeah, I work in banking sector where there is no dearth of data, but the problem there is a lot of regulations and a lot of compliance that they have to follow, that they're not actually. I mean, you can say that banks are literally laggards in adaptive technology, but uh, you know I mean, a lot of the things that you said regarding big data analysis, software development. So it doesn't move to, I mean, it doesn't seem to, adapt quickly over there. And what they say is, security concerns all the time. So using these models, uh, using any proprietary models, even some open source models like DeepSeek, and I don't think they're, very much interested to adapt it. So what do you think future for those kind of industries where, security is a lot of concerns and, using these agents?
So most of the stuff that we are going to cover, actually, if this is linked to one student who asked like which laptop I should buy. So I gave him 3 answers. If you have money, then I'll recommend buy a M2, M3, or M4 Mac, or not M1 because it may not be available. I myself own M1. Second is going to be the cheapest laptop possible because then we can use cloud for us. Or third is going to be a good gaming laptop. But on top of this, I'll recommend this only. Now, the reason we are just limited to these is because there are going to be 2 kind of models. One under, let's say, 7 billion parameter model, and other which is going to be more than 10. And most probably, if you're crossing this bridge, then we're talking about 100 or 500 billion parameter model. Now, in all the agents that we're going to be working on, these are going to be sort of okayish for us. They're not going to give us the perfect result, but then we can run them locally. And for our use cases, we are going to be referring to Google Gemini API keys and other tools that are available online for free for us, but we are not treating with sensitive data. Having said that, if we had, let's say, I'm an organization and I'm ready to spend around $20,000. It's a big amount for some small companies, and for small companies, even $5,000 would work. I can actually deploy this model locally. This big 500 billion parameter model can today be deployed at $5,000, which is barely 3 lakh. So not using LLMs today or not using AI today is actually just a managerial bottleneck. It's not the cost bottleneck anymore. So DeepSeek is Chinese, yes, but DeepSeek is an open source model. You can download it and run locally. A lot of people are actually doing it today.
And is it going to be the trend?
That is going to be
Like
a
you will
trend.
see.
That is going to be a trend, and in fact, every time we have a Hugging Face coming up. So spend a lot of time on Hugging Face models, and you're going to see that the top models are very interesting. We have DeepSeek R1, of course, but we have this Giants Pro 7 billion parameter model. We have Kuroko 82 million parameter model, 14 billion parameter model, 24. So you're seeing the parameter count is actually dropping down. I personally believe that within a couple of years, you're going to see a ChatGPT 4 or even a 4.5 level accuracy achieved by a 10 billion parameter model. Right, and for example, this particular model where we have Kuroka, where is Kokoro, at 82 million parameter model, it does something which is, I would say, magical. Let me just share this specific tab to get the audio out. 82 million parameter is nothing. This is smaller than the VLC player. Okay, and hear this out.
Kokoro is an open-weight TTS model with 82 million parameters. Despite its lightweight architecture, it delivers comparable quality to larger models while being significantly faster and more cost-efficient. With Apache-licensed weights, Kokoro can be deployed anywhere from production environments to personal projects.
That's how fast things are moving. In fact, there's some, I think I read that today only, that we now have Kokoro on browser also. WebGL. Yeah, so slightly slower. Let me share this tab again. It's called this one only. Let me copy some of my own content. Look at the speed of generation also. This is running in my browser. My GPU is already actually in use. Shivanshu, in the meantime, it's not running for some reason. Shivanshu? Gaurav?
Life is like a box of...
You can't hear this. Go ahead. Shivanshu or Gaurav?
Yeah.
Yeah.
Yeah, so this is Gaurav. First of all, Rohan, thank you so very much for this time. Just help me resolve one dilemma that I have in my mind. So after listening to you, it appeared that people who want to learn agent AI, EAG would be the best course to move forward. That starts in March. But I'm some, and this is the area that I would be most interested in. But I come from a general management background where, although working in the IT industry for 20 years, but I don't have any Python or any language experience. Would you like chalk out a path like how can I get started? I am ready to get started, but don't know. Like, should EPAI be the route to get started and then transition into EAG, or EAG could be the road that I can take right from get go?
Okay, so I'll go back to queries. If on queries I posted this thing, and I'm going to copy paste and paste it on our chat window here as well. Okay. Now, for someone like you, EPAI is not useful. EPAI is a 9-month long course. And in EPAI, we understand how to write APIs and SDKs and go much deeper into Python. This is for someone, I'll say, who's actually in the programming side and they're beginning their career and they want a very deep fundamental knowledge on how Python actually works. This is to understand how Python works, not even programming, right? That is how specific it is. Then we have this course called ERA. This is for someone who wants to train an LLM. You also don't fall in this category. You fall in the management category. So we have EAG for you. But the problem is EAG requires a bit of programming and Python. And this is the intermediate level where you know how do we create classes, how do we write functions and other stuff. Now, specific to that, this 1 hour video is an excellent start. So I'll recommend that you actually take this video and see, enrollment is open till 28th of Feb. So if there's no hurry for this, go through this and make sure that you understand this end to end and you practice yourself. If you can dedicate yourself to finish this particular 1 hour video and follow that by maybe other tutorials also, then you're ready for this. But unless you finish this part, do not just enroll and think that, okay, I'll take care of my course later on. First class is on 8th of March. So we are exactly 1 month away from that. So 1 month should be good enough to give you a good background of Python and get you to speed for it.
Thank you.
Hello.
Yeah, go ahead.
Yeah. As you mentioned that the agents will be the next coming thing, and it's gonna be change the most of the things. So I also agree on this. But as you mentioned that DeepSeek and Llama, all these are the uh, having more billion parameters, and we have to run over there. So is there is like, let's say if you are running locally, and if is there is a way that we can stop that one person asked that he's from the banking side, even though we will establish a local server and we will establish this DeepSeek locally. After that, is it there are possibilities that data is not going outside to make sure that DeepSeek is not taking the data from the back end?
Yes, the answer is yes. DeepSeek is not an agent. DeepSeek is an LLM. Given an input, it's going to give an output. It cannot call a function. That code is something that we have to write. That's what we write in agentic AI. So when we are writing our code, we need to make sure our code is not hackable, or our code is not sending data somewhere else. So it's up to us. It's not a DeepSeek that can do it.
Okay.
And today we have things like Olama, where you can actually install these models locally also. And DeepSeek has multiple models. It has 1.5 billion parameter models, 7 and so on. So if I go inside, for instance, and let's say 7 billion, let me pick the smallest one. Right?
Actually, I tried it locally.
Yeah.
But our organization said that just remove all those things. Don't try to use it. But I try to explain them. This is in our local server. There is no need to be fear. We are not using their servers to get the answer, but we are actually launched this in our local server like this. But this challenge is there. So how to identify that it is not giving anything outside, and we need to,
No,
because
it's
I
not
checked.
giving anything outside, but it takes a bit of time for people to agree. What are some of the good blogs and the stuff? One, as I said, is Simon. So do follow this guy. Really, really good. Then I found something very recently in news, and this again was recommended by Andre. So second is this, and third is going to be Twitter. Follow people like Andre Kupathi or other giants in the AI side. Are we skipping LLM AI engineering? No, definitely not, because those are the building blocks for this particular course. The title may not explain that properly, but even from the first or second sessions, we are going to be making sure that we are taking care of the basics, right? Which is prompt engineering. Prompt engineering is not fake science. It is actually a very deeper, has a very deeper use case. So prompting, evaluations, element charge, RAG, all of that is a part of it. RAG, in fact, we have a lot of sessions on RAGs. Balaji?
Yeah, I Rohan. See, I'm into the computer vision domain. I am following your courses from the EVA thing, and totally now I have 7 years of experience. Like last 5 years to 6 years, I completely worked in developing CV-based applications. But from last 1 year, in my current company, I'm getting more in Gen AI and LLM based projects. And willingly or not willingly, I have been pushed into the projects and started working into it. So going forward, also I'm getting many development applications working in this part only. So now I was just thinking, it's a good to change the job like from the CV thing to the Gen AI, or still there are good exposure to CV applications as well. I'm just regarding this course or not, just I'm asking on an eye level view, what is the future is like that.
Yeah, see, unfortunately, people who actually train base model on very specialized use cases, the very, very limited cases. And that is happening because the modern tools are becoming really good. For example, there's this tool called Segment Anything. You might know about it.
Yes, yes, yes.
Right now, Segment Anything was trained on internet data. And I was sure that I don't need to even know about this a lot. But then we are in construction, right? I uploaded some of my construction images and
Yes,
I was like
yes.
shocked that it can actually identify even point clouds. So I
Yeah.
do not now need to collect data and train it. There are online services like this, and Segment Anything has open source use case also. And in any company, AI accounts for only 4 to 5% of code. The rest of the code is actually the rest of the code, which is the logic, the web front, the backend, the deployment side, the CI/CD, the data set that you're managing. So what you're seeing is actually the reality outside your company also. So even if you leave and try and go outside, you need to either go in a research focused company like OpenAI or Facebook or Meta, who's working on a fundamental object detection level, or you need to be actually scaling up on the other side where now we are into the application development mode. So I believe 99% people are in the application development mode, and fortunately only very few of them are in the agentic development mode, and all the application development mode will be taken over by the agentic mode.
Got it. Got it.
Yeah, so building on the same question, and I am facing the same issue. So we should transition to mostly NLP and Gen AI kind of work.
Yes, yes,
And you think these roles are vanishing, just pure building models,
yes.
startups.
It's not scalable because you can't compete. See, problem is that even though it might just take $10,000, or see how the funny part is, DeepSeek says takes $5.5 million to train. Okay, let's say it's true.
Mm.
It's not, but let's say it's true. Which Indian startup can spend 5.5 million to train a gen model, knowing that next week or next month something else better might come in? So we do not have a
Yeah,
venture ecosystem or a industry ecosystem where we are ready to take that risk. So we are short-handed from there itself. So even if we become really good in training models, there are going to be very few use cases for India as such in India.
yeah. Although I would say in niche industry, it is still existing. Like I work in medical domain, there's still niche use cases where we have to build our own
Yes,
models. It's the
yes,
SAM and nothing works. So there might be some roles like those, but yeah, few and far between.
yes. And the amount of funding you will get to test out something, your boss won't come and say, "Hey, it's $1 million for you for this month. Test out something." You'll be given a target. You need to achieve that accuracy with this limited amount of data, with that amount of time, and that amount of compute.
Yeah, that is reality. We are not given compute as such. So, yeah. So,
May I know the future prompt engineering roles? Okay, so there are two kind of prompt engineers. One on LinkedIn, who say, "Do you know these 25 prompts?" Those are shittiest or the shittiest jobs if exist or roles. But the actual prompt engineering role, where you actually have to deal with the internals of LLM, is actually going to increase. Let's see this. So chat GPT prompt system leak. See, there's a big deal, and there's a Reddit thread on it. Seems like the ChatGPT internal prompt has been leaked.
You
And
aren't sharing anything, Rohan.
sorry,
You aren't sharing your screen.
sharing my screen. So here was a prompt. This is the prompt that is sent to ChatGPT earlier whenever you were talking to it. So it's told what it is. It doesn't know what it is. It has to be told every time. Designed by what? Knowledge cutoff, current date, tools in Python. It is a Python tool, detail, do not do this. So all of that is actually required. How do we want output? This is prompt engineering, and this we are going to rely heavily on this when we make our own agent also. So for example, if you go to small agent GitHub library, you're going to see that similar prompts are required there as well. So if you go to small agents prompts, and we have code and tool calling. In both the cases, you're going to see that this is a system prompt. So we are actually telling our agent that you're an expert assistant. You can solve any task. You can use code blobs. This is how you want to use it. This is a task. This is how I want to think. This is how I want you to print out the Python code, and so on and so on. So even before user interact, we can see we populate the model with so much data before even it starts talking to you. Right? So when we say that a model has 10,000 tokens, let's say we talk about 10,000 tokens, okay? Control is C, and then let's go to tick. What is it called? Tick token.
Okay. Yeah.
And let me just paste that text here. Out of the 10,000 tokens, I've already used 3,748 tokens. That's the input that goes before even a user starts interacting. So prompt engineering is super, super critical for us.
Question.
So,
Uh,
go ahead.
I think this is kind of a bootstrap kind of prompt, right? Which is kind of a static, since it's kind of a bootstrapping the model with the initial prompt.
That's correct. These are initial
And
system prompts that are required to initialize an agent.
And I believe there might be certain strategies to reduce the token count. Maybe like don't read it at once, or maybe read it during the training phase itself, or maybe some other technology, some other
Models
way.
already trained. This is sort of guiding the LLM to do a specific thing. So this is required, and most of them are not going to be dynamic in nature.
Right.
Soma?
Rohan, we are working on, I mean, like an agentic AI use case itself of app modernization, basically trying to migrate our legacy apps to modern stack. So, like the approach we took is basically first create the documentation of your legacy apps, because I'm sure like no companies would have that, and then based out of the generated document generate your new code. But then there would definitely be some human in the loop in every stage, right? The capstones, what's this? Okay, the capstone project we are trying to build, will that also have some human intervention, or it's going to be completely agentic with no human intervention at all?
Some human intervention will always be there. It's just going to reduce from time to time. Initially, we'll like to see how the agentic AI is thinking and then proceed forward. But finally, we'll have a system where the intervention is going to be low. It's never going to be zero. We'll always have a human in loop.
The reason I asked is, with these reasoning models coming in, is it going to really change that part?
It is going to change that part. So I just want to show you two graphs. One is a table comparison here. Again, anyone who want to understand the LLM as a site, watch that Andhya video, very insightful. So here we're seeing two things. One is a R10 pass. So a number of problems it could solve at one pass. But look at a 16 pass. These are number of problems it could solve if it attempted a problem 16 times. Look at where O1 was, and O1 was a big deal, 85%. Now this is approaching higher. But apart from this, look at this chart. This is the total number of tokens the model generated while it was answering. So it is actually increasing the total number of outputs as it's trying to solve a problem.
Correct, because it retries the tokens.
If you see how the tokens are being sent out, what the model is doing here is it's trying to break the problem in smaller and smaller and smaller and smaller topics. And that is why the token count is increasing. So when you send a big problem, it will actually solve the problem by first simplifying it as much as possible into thousands of different steps, and it starts solving those 1,000 steps. And that's how a good engineer also solves a problem. So this is a very interesting relation that these people found, that as we're actually solving more complex problems or getting better, our model is actually thinking more before it's solving that. So,
Rohan, by any chance, do you have you come across any papers or blogs related to this modernization work?
no, not yet. I've not
Okay.
searched for it, but I've not come across naturally.
Okay, sure. Thank you.
Kishore?
Hello, hi, Ron. Yeah. So, I mean, for the people who wants to build something, I mean, before it was, you would have to know how to, develop. You have to know the development skills and to build just a web app. But in the AI era that we are right now, so uh, like knowing these AI tools, I mean, which are constantly changing, is enough, or what's going to be the moat kind of thing? Is it the idea that you have, or because the technology is rapidly evolving, and uh, yeah, that's my question basically.
Okay, so we have this, and then let's look at chat. And right, so if you see here, we have Claude, we have GPT, we have Meta, and we have others. And then if you go on chatbot, it's opening up. Livebench here is talking about OpenAI, DeepSeek, and then we have Google, right? Now we have DeepSeek is there for some time, but I think that it's going to drop down, and maybe it's going to be super useful because it's open source. That's why it's going to be on top. But there are going to be a set of companies who are always going to be up ahead. Now, interestingly, all of them have tried to enter the coding side, but it is Cursor that is actually winning the battle. So for each of the tool, we'll have a leader who's going to be taking that particular tool ahead. So if you're using the advanced tools, it's guaranteed that whatever is happening at the front end of technology is going to be directly incorporated in that tool, and you'll have exposure to those tools. So from tool perspective, you're safe. You can pick the best tool, and that tool is going to automate some of the things. So now if I'm using Cursor here, I can show you that I have access to every model I can think of. So right from using Sonnet to Gemini Flash to OpenAI, every model just integrated. So all of these are like algorithms or different calculators for me. So I don't even care about which model I'm using because I'm paying for it. I may use the best one. So that's from the tool perspective. Now, the new agentic AI systems and platforms, other likes, are also going to be there to make something, right? But the main problem is, what is it that we make? So there are two problems here. First of all, we have to come up with ideas of what to make. Second is we need to know the tools that tell us how do we make. Now, initially in the class, I explained that I made these special tools. For example, another problem I face whenever I have my own class is that when I open a session, there's a lot of clutter all around. I have this I don't like, I have this I don't like. So before, I used to go to inspect tools and select all of these manually because there is no option for me to just get rid of all of them, right? Then I'll go there and delete it. But now I just made a simple tool, and this tool literally took me, I think, half an hour. Remove diffs and done. In fact, I added a bit of other tricks also. I added like, hey, why don't you start the camera for me? So it will take the feed from the camera. Right now I have my camera feed going to somewhere else. That's why it's not opening up. But I can just do that. Right, so what we are going to build is something that we need to come up with, and my students for the ERA course came up with amazing applications. The going to Netflix and trying to figure out which is the best movie this week, to astrology and other stuff. So to come up with new applications is going to be the human ingenuity, but if you don't know the tools, then the idea is just going to remain an idea.
Okay, thank you.
Karthik?
Rohan, so I wanted to ask you about so we have been building like an in-house rack for the last like 18 months or so at my company. I think we have gone through that journey wherein like now it's able to answer like simple questions and even like some of the reasoning ones. But then we are facing issues in terms of like sometimes understanding the user's intent, especially because users sometimes ask very vague questions, right? So when you say that we're going to cover RAG in this, are we going to go like are we going to go down the route wherein we create like an in-house RAG, or like what's going to be the scope, especially on the NL to SQL side? I think the unstructured retrieval we were still able to crack, but the SQL piece is still like something wherein like it works like 60% of the cases, doesn't work always.
Our use cases are going to be generic in such a case that people in general have an idea. But if you're talking about solving that specific problem, I don't think we are going to be going in that route. Having said that, we are going to be from the agentic level, be able to understand whether the user query is going to result in a proper answer or not. So in RAG, you just get a query and you have to figure out some data and report back. In case of agent, we're going to get a query. We're going to ask the user again, do you think your query is right or some change is required? Get a better query and then actually query the system. So that's the main difference between the agentic way of RAG and just the RAG.
Got it. Okay, cool. Can chat more once we get there. Okay.
Okay.
I'm sorry, Rohan. Like to convert that query into a prompt into a SQL query, do you mean that a different agent is going to take care of that in a RAG application?
That's
Like if I
correct.
want to query a tabular data.
If you want to query a tabular data and from the query we are not able to form a proper SQL query itself, we need to ask the user again, right? But currently the way RAG works is unidirectional. Got a query, figure out something, report back. So there is no intervention in between where we actually go back to user and say that, can you be slightly more specific?
Okay.
So we have 7 more minutes to go. If you have anything that you've not asked him. Yeah. How can we identify companies that actually deal with AI? Look at the engineers that they have. So that you're not alone. When people say, in fact, I'm going to talk about my own company. Let's look at Incas.ai. The domain has AI. Then I don't know how many times we say AI. The website is also going to change. Yes, there's mesh segmentation AI, object detection AI, defects AI, health and safety AI, and so on and so on. So my own websites talk about AI a lot, but it's not even 1% of the code base. So AI model itself is a very small thing. End thing is the end application. Now, my application of the code that we've written, we actually wrote the segmenting AI. And I believe we are the only one in the world who did it. You see a segmentation map here. This was generated through an LLM. So I personally trained an LLM and trained it on the mesh data and then made sure that it can actually identify columns and capitals and floor and ceiling. But that's all. After that, the use cases that we show the color beautifully, we identify, we annotate, all of that is manual code. So you will have a lot of companies saying we are using an AI and then etc. So again, there are two classifications. One, just using something from cloud, and second is actually training a model. Now, in your case, when you're applying for a job in a specific company, you don't ask them, have you trained a model from scratch? And if you say yes, just ask the data set. What data set have you trained it on? And if they respond that, I think that's the maximum you can anyways get in an interview out. And you can see those kind of engineers already working in that company. So if a company does not have a ML deployment engineer, then you know that they probably have someone who's using just a OpenAI API. Kevin?
So I was just curious, like, how do you keep yourself updated, like in terms of like time spent, and yeah, I'm kind of impressed by you, like how uh, uh, you've been doing things. So I'm just curious, like how do you manage your time or spend your time and kind of to keep yourself updated?
It's the okay. So we all actually have a lot of time. What we don't realize is that 1 week, 7 days is actually around 2% of a year. It's a lot of time. And if I take 30 minutes out every day, that actually accounts for 4 hours a week, because maybe there's a spillover also. 4 hours a week is a lot of time. Now, I want to double down on it. So that means that I dedicate my Fridays and Mondays for whatever I have to do on Saturday. Monday, because I know that my week is going to be busy, and Friday, because maybe it was busy. So if I take this specific amount of time from my life, then a lot can be done. And my schedule is like by 5:30 I'm up and I start my day. So I get morning 3-4 hour clean hours also. But on top of that, it's the set of those questions that I know my students are going to be asking. For example, I had this question, and believe me, yesterday was the first time where I felt that, okay, now I know. in LLM, we have this query that comes as X, right? Like X is the prompt. Then for some reason, we have this K projection linear layer, then we have V projection linear layer, and then we have Q projection linear layer. So we send X to all of them and we make a K out of it, V out of it, and Q out of it. Then we do K, Q transpose and then divide by DM, etc. And then we send it to softmax, that becomes our attention. Then we multiply with V, and then finally we have an output. Now this output, we again take our X and add to it. Fair enough. I can understand this. We need to multiply because we're trying to pass on, understand the relation of one to other. I understand this because this is coming for the scaling issue. I understand a bit of this also, but I've never understood this. Why the hell do I need 3 different linear layers? So I trained one model without using this. What happened? It didn't train. Second, I had a FFNE kind of thing. I realized that each token, 1, 2, 3, job inside a neural network is to actually become 2, 3, and 4, right? That means that this token wants to know what is it that it wants to become. So it has to interact with itself, because in the process it's becoming 3, it's going to be 2.5 also. So it needs to interact with itself, and it needs to interact with this guy. So this guy has to have at least 2 forms. One form where it is 2, its original form, and second form where it's actually in the process of becoming 2 and 3. And that's the query. And once it figures out what it is it has become, it has to update someone. That's the V. So finally I figured K is the true 2. Q is the process of becoming 2 and 3. And V, I'm still trying to figure out what exactly it is. And that's why I'm actually running this specific experiment right now. And if you see what I'm training here, I changed the model a bit and I'm running this small LM2, I believe. It's not showing me the code, but I think it is going to be 2_2 or 2_1. I'll just show you the model, what these models are. I think it's null in only. So here I just have a Q projection. I do not have the V, K and V projection. So I'm saying my K is equal to X and my V equal to K. And I'm just using Q projection because I believe Q is what this token wants to become. That's a query. And I'm just using it. And till now, I've actually not seen any change of loss. I've recorded my old loss and checkpoints also. And I'm now trying to figure out. And it's not doing bad because it's just hit 2.9 also loss. And it's a very small model, 150 MB. 150 million parameters. So understanding environment sensitivities, walking the room filled with all the sort of things, cars, and cars. We can see that it's not a great model yet. Have you ever wondered how these cars work? Well, it's all thanks to something called social number, right? So it's getting in the coherent side. Now, doing this experiment last year was not possible. I was as curious last year also, but now I have cursor. So that is exactly what has changed. People like me, or you, who are very curious and they want to figure out things. Now, this is something I ran at night just before I slept. 5 minutes it took to write a prompt. In fact, you can see my prompt also. This was the auxiliary loss, so that is MOE. After that, can have the main code, fair enough. Then yes, so I'm talking to it. I'm trying to explain to it. This Python file has a normal independent implementation decoder only transformer where we send the input IDs and we shift the logics to output, compare the outputs. I want to change the behavior. I want to send the input IDs, then additional input empty tokens, make the model predict all the sent tokens plus the next token. This was one more experiment I wanted to run. So I didn't do that. I thought that I'll just make an encoder only. Then I realized, oh, it's an encoder I don't want. Yes. So I don't think that's correct, not even a correct spelling. I want a Q8 and other to act like the biases that are element-wise multiplied. This is one more experiment I did. So to now do these experiments, it actually takes like a few seconds and just run it and just keep running it. But it's the thing is, what is it what you want to solve? Keep the problem in your mind, and whenever you get time, just solve it.
Yes, sir. Thank you.
And most important thing for me is essentially School of AI. The reason I can stay ahead is because I have to teach. So if the third class is going to be on some specific topic, I need to make sure that a week before that I'm really good at it, because anyone can ask any question. And I think a lot at what is the kind of question people might be asking. May I know the future scope of RLHF engineering roles? Might be dim. And the reason is that we are getting HF free, human feedback free approaches, where we have BPO and we have PPO. Right, so we are getting in this particular direction. So RLHF has a lesser and lesser feedback, and it's going to be reducing only. See, the problem in RLHF is human feedback, reinforcement learning, human feedback. Which human? Are we talking about a congressman, BJP, or someone who is a vegetarian or a non-vegetarian? So you understand the humans, right? We have our own preferences. I have my own preferences, biases, and based on the biases, if we train a model, then model also going to have that. And if I'm really angry, my response is also going to change. So human feedback is sort of in that particular mode. So it's not really grateful from that point of view. That's why that's the last stone that's left for AGI. If you think about it, how do we remove this last RLHF? We want RL only. We do not want HF there. The moment we are able to remove that HF, you're going to see that we can do something that AlphaGo also did. So I think that it's tricky. We will cover distinction between. We will cover the distinction, but will not be training them. Training them will be out of our overall course structure. That's going to be part of ERA. Do you think research teams at mid-level companies exist in future? Not ones building foundation model, or will companies build smaller outsource even non-core work outside? What I feel is that within 6 to 7 months, already has started by the way, within 6 to 7 months we'll have really good higher AI engineer as a service models coming out. So mid-level jobs are going to be very difficult to maintain. So my overall job perspective is only two kind of jobs that are going to be left. One is going to be where the human touch is involved. Even though AI can do it, but because you want human touch, you will not send it to AI. For example, a doctor. AI can do everything a doctor can do today, but we will not replace him. Or a accountant looking at your black money. Yeah, I can do it, but the guy is still going to be there. So accountants are safe, and CA and CS are safe because they're going to advise some things that an AI definitely wouldn't. Lawyers are safe because you want to feel secure and private and do not. A lot of other jobs that lawyers also don't want to do, like writing your home lease agreement, that might be taken over, but serious cases are going to be there. And the second job where we have a scale of performance, we have scale starting from 0 to 10. Anyone who's above 9 or 10 will be there, but anyone who's mediocre, 80%, 78% actually, not required. Not 78, 88%. So anyone who's above 88% in that particular, so let's say there's some qualification criteria. So if you think that you're above 88% in that role, then you're safe. Everyone here is going to be gone. By the way, not everything is sad. This also means that a civil engineer, after finishing civil engineering, is not working in IT. He will work in civil as a civil engineer. So that's a good thing. So don't be sad. But you're not civil engineer, I know. All right, guys, this is it. And if you have any last question, happy to take. Otherwise, I'll try and do this more often. I realize that there are a lot of open questions also, so I can take care of them. Karthik?
So Rohan, I'm guessing you will be publishing like the syllabus of the course, right? So what
Syllabus
would you
of the
recommend if someone wants to come prepared for like every lecture? Like
syllabus of the course is
something?
already posted on the website, and I do not want you to come prepared. It's a completely opposite approach where the content is shared after the class is done, because there's a specific way in which I want everyone to go. Now, if I share the content in advance and you think that you can actually cover it and you can come prepared, the problem is not everyone will come prepared, and the class goes in a direction where just focus on one or two students, and that's something I want to completely avoid. Second is there's a way in which I want to think about things, and if we are not following that process of thinking about things, then we again get lost. And online, there's a lot of crap, and sharing it in advance will mean that you'll do Google search and then you get into a loop which is not required. So the way the course works is this is extensive, but this is also small. And the way we do that is by making sure that none of the irrelevant content is ever covered. Now, even today, and this is my 8th year of teaching, and I'm a mechanical engineer also, and I've been doing programming for 15 years. I do not know how KNN works, and I do not want to know how KNN works. If you ask me random forest, no idea. So I've made sure that the things I know really good, and things I don't know, I just know what they are, but how they work and why they work, I'm not interested in that at all. And that's how the course is also going to work. There are a lot of ways in different fields which we can go and start learning, but is it required to learn? My job is not only to teach you, but to make sure that you're getting to learn the right things also. Otherwise, this course can be a 2-year long course also, and nothing will be done. That's why I'm making sure that the content is released only after the class, and we go through in the class through that content together. And there's a brothership also built in that case, where you know that I'm with you in that pain and understand topic by topic, and then from there we move on to the next one. To be ready for the course, there are 3 things that you need. And those are 3 links I shared also. Make sure you have good intermediate level understanding of Python. Second, you're good at Git. And third is that the 3 blue, 1 brown neural network series you have gone through, get some idea of why neural networks are working already. We haven't received LMS details as shared on the form. LMS details are going to be sent on 6th of March. It's going to be empty anyways. So on 8th, you're going to get your first content. All right. So thank you, everyone. Have a very beautiful Saturday, and I will see you on next Saturday, next when either the class starts, or I will open one more session again, just randomly. I thought it's a good idea, and hope to see you again.